Before we start, try something strange for a moment. Forget the name of your city. Forget the ceiling above you. Forget the little rectangle of light you're watching this on. Just notice one thing, the space behind your thoughts. That dim, quiet room in your mind where ideas appear before you can explain why. If you sit there for a second, really sit there, you may feel it, a pressure that isn't sound, an awareness that isn't a voice. The same kind of pressure you feel in a dark hallway when you know all the lights are off, but you can't quite shake the feeling that something else is standing still with you in the dark. Now stretch that feeling outward, past the clouds, past the planes, past the neat paths of planets they drew in your schoolbooks. Somewhere out there, in a cold region of space that has never heard a human name spoken aloud, a very small light did something very simple. It did not flare. It did not shatter. It did not announce itself with drama. It began to die, slowly. A shard of ancient ice called 3I/Atlas loosened its grip on existence one photon at a time, and in that slow, reluctant dimming, something appeared that should not have been there. Not a beacon. Not a pattern written in radio waves. Just the faintest, repeating shiver in its own dying brightness, buried so deep in the numbers that no human eye could ever see it without help. If a comet can have a last word, a final breath pressed into the fabric of the sky, what exactly was Atlas trying to say? And what if the truly unsettling part is this? The warning may not have been about the comet at all, but about the invisible structure of the space it was passing through when it slipped out of our sight. By the time Atlas entered the final nights of its watch, almost everyone had stopped paying attention. It had done nothing loud enough to compete with supernovae or exoplanets or the bright, human-sized dramas closer to home. No trending photos. No dramatic close pass. On the screens that mattered, it was a pale smear just above the noise floor, a ghost that required as much faith as hardware to keep tracking. Observatories logged its position the way doctors check the pulse of a patient they already know will not recover. Gently, out of duty, not expectation. The light curve, the graph that turns a comet's brightness into a story, was doing exactly what it was supposed to do. Night after night, the points marched downward in a graceful, predictable arc. No surprises. No spikes. Just a coal cooling in a fire no one was tending anymore. If you had glanced at the plot then, you would have closed the window and moved on. The story, it seemed, was over. But stories in astronomy don't end with what the eye sees. They end in the back rooms, in the quiet offices, where people who have spent their lives squinting at jittery lines and grainy images ask one last question before closing the file. Does the data behave? That is where Atlas refused to let go. When the final nights of measurements were stacked, layered and averaged and cleaned the way you might layer faint pencil marks to see if they add up to a shape, an odd, almost invisible oscillation appeared. The comet was fading, yes, but it was not fading smoothly. Its light dipped, then climbed back a little, then dipped again. Not dramatically. Not enough that you could notice from one night to the next. Just enough that, statistically, it looked like a tired heartbeat still trying to keep a rhythm long after the body it belongs to has decided it's time to stop. On a human axis, it was nothing. A wobble on a graph. On the axis of the instruments, it was stubborn. It recurred across different telescopes, different skies, different hemispheres, different teams. A faint up and down pattern riding on top of the overall decline, too regular to be shrugged away as a one-off glitch. Noise is chaotic. This was not. At first, everyone treated it the way you treat a flicker in a light bulb. Annoying, ignorable, probably wiring. A miscalibrated flat field, perhaps. A cosmic ray that snuck through the detector. Thin cirrus clouds drifting across the line of sight. The universe is not tidy, data rarely is. But the more they tried to crush the oscillation under corrections and recalibrations, the more it slipped out from under their efforts. Filters were changed. Reduction pipelines, those long chains of code that turn raw photons into numbers you trust, were rewritten and run again. Old calibration frames were thrown out. New ones were taken. The comet's rotation was modeled, then remodeled. Known jets of outgassing were included, excluded, exaggerated in simulations just to see if they could mimic the effect. Instrument logs were combed for warnings, temperature spikes, voltage dips, slight misalignments on those particular nights. Every time they thought they had found a plausible culprit, they removed it from the data and looked again. And every time in those last nights, the same faint pattern resurfaced. A slight sharpening and softening of light that did not match rotation, did not line up with known jets, did not show up in any of the usual "I broke" signatures from the hardware. If it was a glitch, it was one that had somehow found a way to coordinate across systems that were never meant to talk to each other. On its own, that might have remained an oddity, a footnote at the bottom of a paper. There appears to be a weak late-stage variability of unclear origin, likely instrumental. But the comet's light was not misbehaving alone. When someone had the reflex to overlay that faint brightness pulse with another plot, the one showing tiny differences between Atlas's predicted position and its actual measured one, the coincidence they saw was the kind that makes a room go quiet. The light was flickering at the same time the comet's path was twisting. By then, Atlas's tail should have been a rumor, not a structure. Early in its passage, it had worn that long, cinematic plume, a soft, cyan streamer of dust and gas blown away from the sun, the sort of thing that ends up on posters and textbooks. As the comet faded, that plume thinned, its brightness sliding below the point where casual skywatchers, and even many telescopes, could follow it. Most people assumed it had simply dissolved into the dark. But deep exposures, hours-long stares from patient instruments, told a different story. The tail had not stopped speaking. It had simply lowered its voice to a register where only those who knew how to listen could hear it. When those long integrations were processed with fine-structure tools, algorithms designed to peel apart the faintest patterns in a haze of dust, a set of ripples emerged. Not big, not obvious. Concentric wavefronts running down the tail's length, like the rings around a stone dropped into a pond whose surface you can barely see. They were weak. They were almost theoretical in how easy they were to doubt. And yet their spacing was consistent in a way that random turbulence from the solar wind shouldn't be. At that late stage, Atlas's outgassing, the jets of vapor that can shake and twist a tail early on, had mostly gone quiet. Any remaining jets would have been erratic, noisy, not arranged into neat, recurring waves. But there they were, gently repeating structures, as if some invisible hand had brushed through the dust and left behind a pattern in its wake. The more closely they looked, the more the comet's last days refused to align with the tidy picture in their heads. In those same late images, Atlas barely clinging to visibility, a ghost on the edge of instrumentation, the predicted path that had fit so well for months began to drift. When scientists refine a comet's orbit, they expect the residuals, the tiny gaps between where the model says the comet will be and where it actually is, to shrink over time, converging toward zero. It's the satisfaction of watching a drawn curve and a set of points slowly settle into agreement. With Atlas, the opposite began to happen. In the last few weeks, the residuals didn't just refuse to vanish. They rotated. Millisecond second by millisecond second, they took on a sideways component, as though the comet were being eased gently off the expected track. The shift was minuscule, the kind of deviation you would never notice if you were looking for danger to Earth, or trying to plan a spacecraft rendezvous many years down the line. But in the quiet, obsessive domain where orbital dynamics lives, small is just another word for, you're finally seeing past your blind spots. When they stripped the equations bare, removing, one by one, every force they knew how to model, solar gravity, planetary tugs, pressure from photons, the tiny rocket pushes from vents of vaporized ice, the motion that remained refused to vanish into numerical dust. There was a residual acceleration coherent in direction and timing, that sat there like an ink mark on otherwise clean paper. The easiest comfort was to blame the model. The code is wrong, is a safer sentence than reality is different. But as they checked and rechecked, as independent groups replicated the effect with their own tools, a different possibility began to push through. The problem was not that the universe had broken its rules. The problem was that the set of rules they were using was incomplete. The last signal of Atlas was beginning to look less like a comet misbehaving and more like the universe, through the comet, pointing directly at an empty line in our equations and waiting to see how long it would take us to notice. So they did what astronomers do when something refuses to fit. They stopped staring at the object and started staring at the background. Along Atlas's path, especially over those final nights when the brightness shivered, the tail rippled, and the orbit bent, they began stacking images of the starfield behind it. Gravitational lensing, the slight bending of light caused by mass, is normally a game played with galaxies and clusters and vast, distant structures. You don't expect a fading comet to participate in that conversation. But Atlas was already carrying the rumor of an unseen companion from earlier in its flight. If that companion existed, some concentrated weight moving with it, then the best way to catch it might not be to look for its glow, but to watch for how it made other things misbehave. So they watched the stars. For most of the comet's journey, the background behaved like background does. Distant suns held their positions from night to night, anchoring the coordinate grid. Then, on one particular night, inside the same window where Atlas's brightness pulse peaked and its residuals twisted hardest, a handful of those far-off points jumped. It was not a dramatic, cinematic warp. No elegant swirl of arcs around a dark center. Just a subtle, measurable displacement. A fraction of an arcsecond in a handful of stars clustered in a small region of the image, present in several consecutive frames and gone before and after. It was the kind of effect you could only see by stacking images and subtracting baselines, by letting software align thousands of pixels to within fractions of their width. Different teams using different reduction pipelines, some homemade, some standard, some deliberately blinded to avoid confirmation bias, reported the same thing when asked to analyze the images without being told exactly when the event was supposed to occur. A slight, localized twitch in the starfield that coincided with the comet's strangest behavior. If the comet's last light curve was its whispered breath, this was the faintest footprint. Space itself bending and then relaxing as if something heavy had moved through, then stepped away. To make sense of any of this, scientists had to stop treating Atlas's death as a sequence of isolated oddities and start treating it as the visible edge of a longer, hidden interaction. So they rewound the tape not just in space but in meaning. Using refined orbital parameters, they ran the comet's trajectory backward along the months and years of observation, plotting every anomaly they could find, each tiny wobble in position, each slight oddity in tail structure, each murmur in its brightness, against where the comet was relative to the suspected path of its unseen partner. In the early approach, hints appeared, small residuals that pointed the same way, strange subtle bends in the tail when Atlas crossed certain celestial longitudes, but they were messy, drowned in the noise of a warming, outgassing nucleus responding wildly to the sun. Only in the exit phase, when the comet had grown simple, colder, quieter, stripped of its most unpredictable vents, did all those threads twist together into something that felt like a rope. The ripples in the tail, the pulses in the light, the sideways drift in the orbit, the brief lensing of the background stars. All of them clustered in a narrow band of time and geometry, like instruments in an orchestra that had been tuning randomly for an hour and then suddenly all struck the same chord. The realization landed not with drama, but with a slow, spreading unease. The last signal wasn't necessarily a new event at all. It was simply the first moment when our measurements were clean enough, and Atlas was quiet enough, for the underlying influence to step fully into view. Everything beforehand had been prelude, half drowned by the comet's own noise. Only at the very end, when Atlas resembled less a messy venting rock and more a simple, obedient test mass, did the unseen hand guiding it become unmistakable. In the small rooms where the language is equations but the air is thick with unspoken feeling, the mystery began to take on three main shapes. 1. An unseen compact object, something like a small black hole or a hyperdense remnant, traveling with Atlas in a loose gravitational partnership, its mass dominating the motion while its invisibility dominated our confusion. 2. A pocket of dark matter, a local thickening in the unseen scaffold that threads through the galaxy, a cloud of weight with no light wrapped inside it at all, through which Atlas passed like a leaf drifting along the edge of an invisible river. 3. A moving scar in space-time, a ripple or defect left behind by some event long gone, with no object at its center. Just a region where the rules are slightly warped, and anything that passes through will feel curvatures our equations don't currently account for. Each of these stories could replay parts of what Atlas did. None of them could perform the entire piece without missing notes. The flickering tail suggested gradients in gravity. The brightness pulse hinted at internal stress, flexing, cracking, healing. The lensing event screamed mass or curvature. Together, they formed a sentence that sounded less like, "This is what I am," and more like, "This is the shape of what you are ignoring." The first possibility, the black seed, was the easiest to picture and the hardest to sit with. Astronomers have long speculated that the early universe might have produced primordial black holes of many sizes. Most of those would have either evaporated or grown into something dramatic. But some might have cooled quietly into a state of deep, unremarkable permanence. No disk, no flare, nothing to announce their presence besides a gravity that refuses to be ignored. Imagine an object no larger than a mountain range but as heavy as a planetary core, wandering through interstellar space for billions of years, slowing down only as it encounters pockets of matter to drag along in its wake. For most of Atlas's trip, such a seed would have been the true conductor of the dance, its invisible mass defining the orbit while the comet played the role of bright, fragile partner. The two would move together, sharing a center of mass that we traced only by watching the one name we could see. Only when Atlas itself quieted, jets subsiding, shape effects diminishing, and only when Earth, the seed, and a particular background starfield fell into a narrow line, would the black seed's presence briefly outweigh every other influence in the data. Tail waves would align with its gravity. The orbit's residuals would peak in its direction. The stars behind would shiver as their light skimmed past its compact, indifferent pull. Then a few hours later the alignment would pass. The comet would continue to fade. The seed would continue along its path, utterly unchanged by our momentary awareness. The warning encoded in this image is not, "something is coming." It is, "something was already here." If one such seed can stroll through our system hidden in the faint glow of a single comet, unveiled only because geometry and timing happened to cooperate for a brief moment, how many others have passed through without a lantern at all? How many subtle deviations in orbits, smoothed over in old data as measurement error, were actually fingerprints of invisible mass we never knew to look for? The second possibility trades a single object for a landscape. In this version there is no compact core dragging the story forward. There is instead a region of space itself that is different. A cloud, if you like, made not of gas or dust but of dark matter. We know dark matter exists because galaxies spin in ways that luminous matter alone cannot explain. We map its large-scale distribution with lensing arcs and background radiation. But we have almost no sense of how clumpy or smooth it might be on the scale of a solar system. Picture the outer reaches of our star's domain not as a clean, empty void, but as a place where invisible density can pool. Pockets of slightly higher dark matter concentration. Streams where it flows a little thicker. Into this unseen terrain Atlas wanders. For months, its path carries a faint bias as it schemes along the edge of a halo, its motion ever so slightly tilted by a gravity no telescope can photograph. Its nucleus feels a constant, gentle stress that we mistake for noise. Only near the end does it cross the gradient, the place where the dark matter density drops away into something closer to normal. As Atlas moves from thicker to thinner, its orbit relaxes, shedding the extra pull like a swimmer stepping from a strong current into still water. That change in environment sends a last ripple down the tail, a last series of microfractures through the nucleus, a last shiver through the brightness curve. The starfield, momentarily, registers the uneven tug of the halo's edge as light bends through a slightly lopsided potential. Here the warning is not about a single lurking thing. It is about architecture. We have drawn the solar system as though it were floating in a smooth bath of gravity defined entirely by the sun and the planets. Atlas's behavior hints that we may instead be moving through a patchy, layered medium, a landscape of invisible hills and valleys that quietly steer the long-term fates of comets, asteroids, and perhaps even planetary orbits over eons. The third scenario walks away from objects altogether and asks a stranger question. What if Atlas was not accompanied by something but by someone? Imagine that, long before our star formed, before this region of space cooled into anything like the quiet we experience now, something passed through, an early black hole, a collapsing defect in a field, a ripple from an event we haven't yet learned how to name. Its passage did not leave behind a remaining body, but it did leave behind a memory, a localized warp in spacetime that never quite flattened out. Over cosmic time, that warp stretches, drifts, softens, but the geometry in that region is still not entirely the same as the geometry elsewhere. Every now and then some object crosses it, a cloud, an icy rock, a stream of dust. Most leave no trace we could hope to detect. Then comes Atlas, fragile and bright, carrying just enough structure to show us how different gravity feels inside the scar. Its orbit bends not in the clean way it should, even with all known masses accounted for. Its tail curves along lines that don't match any combination of solar wind and jets. Its nucleus flexes and cracks in a pattern that feels like it's responding to a gradual change in the shape of space, not to a new force added from outside. On one particular night, the alignment locks in, comet, Earth, scar, and distant stars all in the right configuration for us to see something has gone strange. The starfield twitches. The residuals peak. The brightness pulse reaches its largest amplitude. Then Atlas moves on. The scar remains, patient and invisible as ever. In that picture, the warning is historical. What we call empty space is not a blank canvas. It is a palimpsest, a page written on and erased and written on again. Events long gone can leave signatures not just in the matter they touched, but in the structure of the stage itself. We have been treating the stage as neutral. Atlas's last signal suggests it may be full of old stories. Whatever story you prefer, seed, halo, scar, one fact refused to be ironed out. The pattern did not look like accident. The late-time brightness pulse peaked when the tail waves were sharpest. The starfield twitch coincided with the largest sideways residuals. Independent teams, using different data, different methods, different assumptions, kept being pulled back to the same narrow window of time when Atlas behaved as if it were responding to something more coherent than noise. Comets do strange things. Instruments misbehave. Software hides bugs in places that take months to find. But here, too many small excuses tried to line up as if rehearsed, and the result felt less like a collection of unrelated errors and more like a single, thin, stubborn thread of truth. In a universe ruled by statistics, it is always possible that what you are seeing is a fluke. Perhaps the oscillations were uncorrected systematics in the photometry. Perhaps the tail ripples were an artifact of image processing. Perhaps the starfield twitch was a rare, localized atmospheric distortion. Each explanation is comforting in its own way because it shrinks the mystery back down into the realm of human error. And yet, paradoxically, the more rigor they applied, the more the anomalies refused exile. Cross-checks, blind analyses, synthetic data injected to see how the pipelines would react. Again and again, Atlas's last behavior survived the assaults designed to destroy it. The feeling, as one researcher quietly put it, was like the universe clearing its throat. Not a speech. Not a proclamation. Just a small, involuntary sound reminding you that something larger is sitting in the same room as you, listening to the same silence. As that feeling grew heavier, the center of gravity shifted away from Atlas as a one-off curiosity and toward a larger, more uncomfortable question. If a dying comet can carry this much information in its last light, how many others have done the same, and how many times have we failed to notice? So they went digging. Old datasets were pulled from servers like forgotten boxes from basements. Interstellar visitors that had already come and gone. Long-period comets with odd orbital histories. Objects dismissed decades ago with the hand-waving phrase, probably unusual outgassing. Atlas's filters were applied to them like a new lens. Look at the last weeks, not the first. Search for late-stage brightness pulses. Look for tails that reorganize as they fade, not just as they wake. Examine the orbital residuals near the end for twists we might have smoothed over before. In the dusty corners of the record, hints emerged. One comet with a strange final flutter in its light curve that had been attributed, at the time, to weather at the observatory. Another whose tail showed faint wave-like structures in its last images, then was simply lost to geometry and neglect. A third whose orbit showed a persistent, unexplained deviation near its exit, written off as limitations of the model. None of them were as clean, as beautifully aligned as Atlas. But taken together, they painted a suggestive picture, that we have been walking past whispers like this for a long time, hearing them as isolated murmurs instead of as syllables of a larger word. Atlas's warning then shifts shape again, from a singular alarm to the first piece of a language we are only just realizing exists. With that realization, the comforting simplicity of the solar system's old diagrams evaporated. The familiar image, a bright sun, a family of planets, a few belts of leftover ice, is still true in the way a child's drawing of a house is true. But now, layered over it, is another picture. A space crisscrossed by interstellar visitors carrying hidden companions, textured by dark matter pools and flows, marred by ancient scars in geometry, populated by silent actors that never show up in the pretty illustrations. We are not living in a well-mapped neighborhood. We are standing at the edge of a vast, shifting shore, mistaking the first few meters of shallow water for the whole depth of the sea. This shift did not stay on the page. It settled quietly into the people who stared at those graphs and images for weeks and months. For many of them, Atlas's last signal became a kind of private turning point, a lens they could not help but look through when they approached other problems. Not because they thought any new comet was secretly a threat. Not because they imagined every anomaly would lead to hidden black holes. but because once you have seen how much structure can hide in something as unassuming as a fading comet, it becomes very hard to take "nothing interesting here" at face value. The warning in its most distilled form was not "you are in danger." It was "you are not at the center of the story you are living." There is a peculiar intimacy to being reminded of that. We are wired to think of danger as something with eyes and intent, something that can look at us, choose us, approach us. But the deepest structures of the cosmos do not choose. A black seed does not wake up and decide whom to affect. A dark halo does not adjust its flow out of mercy or malice. A scar in spacetime does not reopen for dramatic timing. They are simply there, woven into the environment the way mountains and oceans are woven into ours. To know that the long stability of your planet's orbit, the quiet regularity of your seasons, the fact that life had enough time to evolve you in the first place, all of this may depend on a choreography of factors that includes actors you have never named, is to feel very small and very exposed. And yet, there is a kind of honesty in it that can feel like relief. The universe is not whispering about you behind your back. It simply isn't whispering about you at all. You are free in that silence to listen. If Atlas carried a warning then, it did so the way all physical systems warn, accidentally. The universe did not choreograph a comet and a hidden structure to align in front of our telescopes as a message. Geometry and timing collided and a pattern fell out. We were there to see it. That is all. Preparation, under those conditions, cannot mean what we usually mean by the word. You cannot prepare to negotiate with indifference. You cannot stockpile shelter against unintentional alignment. What you can do is cultivate a different kind of readiness, the ability to notice, to record, to question. Readiness, in this context, is almost boring in its practical form. It means building instruments that can see just a little fainter, measure just a little more precisely, and, crucially, keep their records just a little longer. It means sky surveys that don't prioritize only the large and the bright, but that quietly record the slow, the dim, the things that look unremarkable at first pass. It means funding the reanalysis of old data, incentivizing the unglamorous work of asking, "What did we miss?" And on the human side, readiness looks like humility. The willingness to say, "This does not fit," and sit with that discomfort instead of rushing to file the anomaly under some familiar label. The patience to resist the urge to force new data into old frameworks just to avoid rewriting the frameworks. The understanding that the real danger is often not what is lurking in the dark, but the stories we tell ourselves that keep us from turning the light there in the first place. One last signal from one small comet implies a sobering possibility, a population of warnings we never heard. If Atlas's exit was sculpted by an unseen companion or structure, and such companions are truly rare, then perhaps we witness something akin to a cosmic eclipse, a coincidence of alignment we are lucky to see once in many generations. But if they are common, if black seeds, dark halos, and moving scars are scattered throughout the outskirts of our system, then Atlas was not rare at all. It was merely the first object and the first dataset that were both clean enough to reveal the underlying pattern. In that case, the warning becomes not cinematic but statistical. We inhabit a region of space populated by silent actors we have not catalogued, and over very long timescales, their accumulated influence could reshape the architecture we think of as stable. A slight uptick in the rate at which comets are nudged inward. A subtle bias in the orbits of asteroid families. Tiny, persistent torques on planetary axes that, over millions of years, change the way climates evolve. Nothing that you could put on a movie poster. Everything that matters to the deep history of worlds. To live with that knowledge, we have to rewire what we mean by signal. We are used to associating that word with intention. Someone sends, someone receives. But the cosmos is full of signals that have no sender. In physics, a signal is simply a change that carries information from one place to another. A fluctuation in brightness. A shift in a star's position. A deviation in an orbit that you cannot account for with your current list of forces. Atlas's last signal, in that colder, clearer sense, is not a message. It is a correlation. A linked set of behaviors, fading light, twisting tail, wandering orbit, bending starfield, that all point in the same direction. Together, they trace the outline of an absence in our understanding and spell out a single humbling phrase. Your model is incomplete. That phrase can sting. It cuts at the part of us that wants the universe to be a finished book we can simply read or ignore. But it is also the most generous thing reality can say to a curious species. Every incomplete model is a door half open. We have walked through doors like that before. Mercury's stubborn orbit nudged us toward general relativity. Galaxy rotations tugged us toward dark matter. The quiet hum of microwaves in every direction pulled us toward the Big Bang. Atlas is not that big. Its last whisper is not that loud. But it may be another small door in that same direction, away from the comfort of we understand, and toward the more honest, more interesting ground of we are beginning to see where our understanding ends. The universe, for its part, has never owed us comfort or simplicity. Stars form and die without pausing to see whether we have finished updating our textbooks. Black holes wait in the dark, indifferent to whether or not we have published our models of their interiors. Dark matter flows along filaments, shaping galaxies that no one will ever see. Scars in spacetime keep the shapes of events that predate every story we have ever told. We appear briefly inside this machinery, carrying the strange torch of self-awareness. We look at the gears and fields and forces around us, and because we cannot help it, we ask why. Sometimes, in our impatience, we mistake interaction for intention. We see a pattern and we want there to be a mind behind it. Atlas's last signal invites us to try something else, to be moved by a pattern precisely because there is no mind behind it. Perhaps the deepest warning hidden in that final flickering light is this: do not confuse indifference with safety. Just because a force does not see you, just because a structure does not think, does not mean you are immune to its consequences. Our orbit, our climate, the relative calm of the last few million years, all of this rests on a delicate choreography of gravitational balances, resonances, and coincidences we are only starting to quantify. Most nights, that complexity is a silent backdrop. Once in a while, a small object like Atlas brushes against the unseen scaffolding and, in how it deviates, reminds us how much we owe to balances we did not design and cannot control. And yet, if we are honest, we must also keep a small corner of doubt lit. What if, after all the analysis, all the care, all the effort, the last signal dissolves? What if future instruments, with even better precision, fail to see the same pattern in other comets? What if the combined weight of new evidence leans us back toward the simplest explanation, that Atlas's final behavior was a beautifully instructive example of how easy it is for humans to find constellations in random stars? That outcome would not make this story foolish. It would make it sharper. It would mean that in chasing the ghost of a signal, we built better tools, tested our methods, learned where our biases hide. It would mean that Atlas had still taught us something, about ourselves, about our instruments, about the line between pattern and noise. In that version of the universe, the warning is turned inward. Your own mind is as capable of bending reality as any small patch of warped spacetime. Be careful. But if the signal stands, if, after the dust settles and the next generation of observations rolls in, there remains a stubborn cluster of behaviors at the end of Atlas's life that no conventional model can comfortably swallow, then the comet's role sharpens into something quietly profound. Not a prophet. Not a harbinger of doom. A teacher that never meant to teach. A piece of ancient ice from another region of the galaxy, passing through once, and in the way it chose to fade, peeling back a corner of the curtain we had mistaken for the wall. Which brings us back to that first picture, a fading coal in a vast, cold fire. Atlas is gone now. Its fragments have dispersed into trajectories too faint for any telescope to track. Whatever walked with it, black seed, dark halo, moving scar, continues on in the dark, unchanged by the brief attention of a small species on a small world. New targets have taken its place in observation schedules. New data fills the disks. The sky, for most of us, looks exactly the same as it did before. But for those who followed the comet all the way down into the noise floor, the darkness no longer feels like a simple backdrop. Feels thicker, textured. Less like an empty stage and more like a medium, one that can carry hidden structures, silent weights, echoes of vanished events that still have the power to tug on passing travelers. The warning hidden inside Atlas's last signal is finally not about doom, not about countdowns, not about a date on a calendar. It is about perspective. We are not the audience for whom the universe performs. We are the fortunate ones who arrived early enough and built carefully enough to notice that it is performing anything at all. As new comets glide in from the outer dark, as fresh anomalies flicker at the edges of our graphs, we will remember Atlas. Not as the disaster that almost was, but as the quiet messenger that, in its last breath of light, hinted that the architecture behind the familiar night is deeper and stranger than we knew. The future, in that light, is not just the path our planet takes around the sun. It is the slow widening of our awareness of the forces and structures that have been shaping that path since long before we learned to give it names. In that sense, the future does watch us back. Not with eyes, not with intent, but with the steady, unblinking gaze of laws that will continue to operate long after our questions have faded into the same silence that swallowed Atlas's light. And somewhere, perhaps not too far in time, another fading object will carry another last signal across our detectors. Maybe next time our instruments will be ready. Maybe next time we will recognize the quiet pattern faster, not as a voice, not as a story written for us, but as a doorway, another chance to see that the universe we inhabit is wider, stranger, more layered than the thin slice we usually live inside. Until then, if you find yourself under a clear sky and the noise of your day drops low enough, you might remember a comet you never saw. You might let your gaze rest on a patch of ordinary darkness and feel, for just a second, that familiar pressure in the space behind your thoughts. Not threat, not comfort, just presence. A reminder that as you stand on a small, warm world circling an ordinary star, other travelers are moving through the same invisible sea. Some bright, some dark, some not made of matter at all. All of them leaving signals we will spend lifetimes learning how to read. End screen line. Sometimes the faintest light at the edge of vision is not an ending at all, but the moment the universe quietly admits it has been hiding more of itself.